Okay, what is the graph? Graph is a nonlinear data structure. It contains node and edge, okay, and which is the node also called this, which is the vertices, okay. And especially we have a node, yes, these are nodes, okay, and which is the edge, which is this one edge, okay, this one, and this all edge, which is the the line, which is the line which is the connected to nodes in the graph, okay, it is edge, okay. And we're gonna see what is the terminology in our graph, okay. We spoke about the edge, okay, and then this is the edge, and we spoke about firstly nodes. Yes, we have a nodes in our graph, and they are connected, each node connected through the edge, okay. The edge is the edge, this is the line that's connected 2 points, okay. And also we have a unweighted graphs, okay. Unweighted, it means, and you can see here, and this graph is unweighted. And imagine this is, for example, ACT, BCT, yes, and the CCT, and this all, and DCT and ECT. I have a 5CT, and this is distance, but I don't know distance without distance. It means if there is no distance, yes, it means this graph is unweighted graph, okay. And also, we have a weighted graph also. For example, maybe here is the 100, yes, maybe, and maybe here is maybe 80. And if like so, yes, if like so, we have a distance between the 2 points and between the 2 nodes. It means this is the weighted graphs, okay. And also we have a directed node, and the directed node, if you see here, this is not directed, and you can see there is no direct. And if I put here direct, yes, and if like so, maybe yes, from here and like so, if I put here, this is the directed node, directed graphs, and this is the directed graph, okay. And also and if there is no indirect, it means undirected graph, okay. And also we have a cycle graph, which is, you can see here I have a directed, which is, you can see here I have a cycle graph, okay, here, okay. And if, for example, there is no any direct, okay, it means it cannot be the cycle graph, it is the uncycled graph, okay. This is uncycled graph. And this is all about the terminology of our graphs. And also we're going to speak about what is the type of graph we have, okay. And the first type of graph is the undirected graph. If we don't have these rows, it means we don't have direct, it means this graph is undirected graph, okay. If you have a direct, yes, I have a direct, it means this graph is directed graph, it is the second one, okay. And also we have unweighted graphs, okay, we spoke about it on the terminology, yes. If there's no any distance, it means the unweighted graphs. And here we give, and this, which is the distance, yes, 100 and 880, yes, and 180, and it means unweighted graphs, which is the fourth type of graph, which is the unweighted graph, okay. And also we have a complete graph. For example, we have these nodes, yes, and this. If I connect all and like this, each nodes are connected, okay. And this node connected to the 3 node, and this node, and this node, and this node, and this type of nodes, okay, this type of node is the complete graph, okay. And especially these are the commonly used type of graphs, okay. And based on this, we can create a new type of graph, okay. We may, okay, and there is no limited, okay. We can create one of the type of graph, okay, based on this, okay. Let's want to speak about the graph representation. And we can create the graph by using matrix, and also we can create by using a list, okay. And let's we're going to see first, which is how we can create by using the matrix, okay. And imagine I have a matrix, and we're going to implement this graph to the matrix, okay. And firstly, I have a matrix, yes, maybe this, okay. And on the columns, okay, on the columns, I'm going to write the A, B, C, D, and E, okay. And like so, on the rows also, I'm going to write A, B, C, D, and E also, okay. And here what I'm gonna do here, and firstly I need to and write that is the 0 here. A to B, I will gonna put here 1, yes, AE, and also AE, which is I'm gonna put here, and here others it will be 0, okay. And after that, we're gonna look at B, okay. Firstly BA, which is the BA, I'm gonna put here 1, and BC also I'm gonna put here 1, okay. And also BD also I'm gonna put here 1, and that's it, and others will be 0, okay. And then C, firstly CB, which is the CB, I'm going to put here, and the CD, and also CD I'm going to put here, okay, 1, and that's it. And I'm going to put others 0, and like so. And also which is the D, and DC, and firstly DC, which is I'm going to put here, which is the 1, and also DB, okay, DB I'm going to put here 1, and also DE, also here I'm going to put here, and a 1, okay, here, and the others I'm going to put here 0, which is the A. And also, and the last one, which is the A, which is the EA, I'm going to put here 1, and also AD, also AD, I'm going to put here 1, and others will be 0, okay? It looks like this, okay? And this is, how we can implement a graph by using the matrix, okay? Let's want to see how we can implement in using the list, which is the array, okay? And firstly, we have an array. And you can see here I have an array, yes, and I'm just inside, I'm going to write the A, B, C, D, and E, okay? And after that, whenever we have, the link, the direct, I'm just write like this, which is it looks like, linked list. And just we have a 2 here, and okay, I'm just here write the B and the E, okay? And like so, which is E. And also we have a B, I'm going to write the B also. And A, and the C, and also D, okay? It looks like this. And also we're going to write the C also. And the C is the B and also D. It looks like this. And also I'm going to write the for D. And I just write the B and the C and also E. And like so. And the last one is the A. And the last one is the E. And I'm just write, I have a 2, yes, which is the A and the D. And how it is, and this is the list, which is the list and array, and how it is looks like this. And this is the matrix, okay? And for implementing in Python, okay, if you are using Python, and we can implement by using the dictionary, okay? And imagine, for example, and I have a dictionary, yes. Inside the dictionary, I'm just, for example, inside maybe string, yes, for example, A, and and here I'm just nested for the list, okay? Inside list, for example, I can store and A, B and E, and like so, okay? And like so, okay? And after that, I can, for example, it will be a representation. I'm just writing, yes. I need a B, yes, it looks like B, and it looks like also array, and and we can. And also, we're going to speak about the graph traversal. And for traversing our graph, we have a 2 common way, which is the breadth first search and depth first search, which is the DS. And firstly, which is the breadth first search and depth first search, okay? Let's going to speak about the first breadth first search. What is the breadth first search is? And the breadth first search, it's iterate from the level of the traversal, okay? It looks like the same, okay? And firstly, we're going to start from here, and we're going to go and here, and then we're going to go here and here and here. It looks like, firstly, we're going to go here, and at the second of the 0 level, this one, okay? And the second level, it is this one, okay? We're gonna go here, and then we're gonna go the third level, which is the second level, 0 level, first level, and second level, okay? And we're gonna go here. It looks like this, okay? Breadth first search. And the depth first search is some different, and the depth first search is iterating from the first, and then it goes to here, and then it goes to here, and then it goes to here, and then it goes to the C, okay? It looks like this, okay? And for implementing breadth first search, we're going to use Q data structure. It will be we can implement on the code also. And for implementing depth first search, we're going to use stack, okay? And okay, it's all about the graph data structure, okay? Let's switch to VS Code. We're going to create our graph data structure, and we're going to implement all functionality, for it traversal, and also we're going to add, okay? And also we're going to create based on the which is the list based on which is the Python dictionary, okay? And let's do it. Okay, let's want to create our graph data structure based on the Python dictionary, okay? And that is, we spoke about the 2 way we can create the graph by using the matrix and also by using the list way, okay, which is the array. And we're going to use the array way, which is the list way, and we're going to implement through this. And firstly, I'm going to create a class and a graph. And inside, I'm just initializing my graph, okay? I'm just going to score init and self, and also graph dict, we are just implementing based on Python dictionary, okay? And inside, first I'm going to check if gdict is none, if like so, and I'm just write the gdict is equal to empty dictionary and like so, curly bracket, okay? And after that, I'm just write the self dot gdict is equal to gdict and like so, okay? And here, whenever we call the whenever we are creating a graph, and firstly we need to check our graph dictionary. We have some, it means, for example, whenever we are creating instance of graph, okay, graph data structure, if we give, for example, none, yes, and it means we are just initializing empty dictionary, okay? If like so, maybe we can give the for example, empty dictionary also, okay, on the parameter whenever we are creating instance of that class, okay? And also, we're going to create the 2 functions, and for adding node, which is the vertex, and also for adding edge to the vertex, okay? And let's going to create this. First I'm going to define a function, which is the add node. Okay, it takes the self and also node itself. Inside, firstly, I'm going to write the one line of code only, the self dot g dict. Okay, and here, for accessing, here just I'm going to write the node is equal to, here empty list. In our dictionary, we have a key value pair, yes, and we have a key, and also we're going to give the value. And whenever we are creating graph based on this inside dictionary, yes, and the key, it means the node, which is the vertex, okay, and the values are the edge of this node, okay. And here, whenever we are creating node, and we are just giving the inside, which is our dictionary, which is empty dictionary, yes, and then we are just defining which is the empty list of the here this, the node is key and the value is empty list, okay. And after that we can add edge to this inside the list, okay. And now we're going to create the add edge function also, def add edge, and it takes a self and also node, and we're going to give the edge itself. Inside that also I'm going to write one line of code, self dot gdict, and I'm just giving here node, yes, and then I'm going to call the append function, append, and I'm just giving it here the edge, okay, and like so. And this is all about how it is add edge function looks like, okay. And let's we're going to create our instance of graph, and just the graph is equal to graph, and here we're going to give the none, okay. And then I'm just call the graph dot add node, yes, and here I'm going to give firstly node. For example, let's going to give the node is a, okay. And after that, and I'm going to call this again graph, and I'm going to call the add edge, and here I'm going to give the what is the edge of this node. And firstly we're going to give the node itself, and then we're going to give edge, maybe edge b, yes, and like so. And let's save it, and let's going to print this, print, and graph dot gdict, which is this one, okay. Save it and open the terminal. Let's want to write Python, and which is the graph dot py, and like so. And you can see here we successfully created our graph, okay. We have a one node and also one edge, okay. Okay, let's implement graph traversal to our graph data structure, which are the breadth first search and depth first search. Firstly, we're going to implement breadth first search. I'm going to define a function bfs, which are the breadth first search, inside self and the node, and inside firstly, and I'm going to define a variable which are the visited, and this visited variable stores the all nodes which are the visited, and which is the I'm going to define the visited as a list, okay, as a list. And here we are just storing, and each node whenever we are visiting, for example, you can see here I have a graph, yes, and whenever I'm visiting, for example, this node, yes, and then I need to store this node inside visited, because we visited it. It means we must market this node as a visited. And then whenever we took this node, yes, and we are iterating all edges related to this, and therefore I'm gonna just write the node, because whenever we call breadth first search we need to give node, for example, a, yes, it means we are visited this node. I'm just putting inside, and then also I'm going to define the one variable. As we spoke about it, breadth first search is based on the queue, yes. It means for creating queue, and I can use list, yes. And for doing this, I'm just define the variable queue is equal to list, and we can we can create a queue based on list here directly, yes. Or maybe you can import queue, and then you can use here also. There is no matter. And here firstly, and whenever I'm just storing also here, and whenever I'm visiting, for example, this node, yes, and I'm just storing inside a queue list, and then I'm just whenever I am iterating this node, whenever I'm printing this node, after that I'm just delete this node. Firstly I'm dequeue this node and inside a while, and then after that I'm just print that node, which is here. I'm just store the node, yes, and then after that I'm just iterate my my graph dictionary, yes, and then firstly I'm going to write here, which is the queue, and here a queue we are just dequeuing every time whenever we're iterating. Therefore I'm just putting here whenever I will reach the last node, yes, after that I just dequeue it, and then we don't have any node inside this queue list, okay. Therefore I'm just using queue here, okay, and inside firstly I'm going to dequeue the queue node, and is equal to queue dot pop. We have a pop function in our list, and whenever we whenever we call pop function, it deletes the first node. It means that which is the dequeue, okay, and therefore, and after that, and I need to print that dequeued deleted node. Okay, I'm just print this and the dequeued node, and like so. Okay, and after that I'm going to write a for loop for iterating my edge belongs to node. Okay, for example, here we have a dequeued node, yes, and I'm going to take this node and then I'm going to iterate all edge belongs to this node. Okay, it means we have a node, yes, here, and then you can see here terminal I have a node A, and then I have a list of edge, for example, and maybe here B, but whenever we are, for example, working with graph, yes, we have a lot of node edge, and therefore I'm just iterating. Okay, and for every time I'm taking edge, and inside the self dot gdect, and here I'm going to give the deleted, which is the dequeued node, and then inside the first I'm going to check using the if condition if which is this edge not in visited. Okay, which is this. Okay, whenever, for example, this edge is not exist in our visited node, it means we didn't visit this node. Therefore I'm just append this node visited dot append, and I'm gonna give that, which is the edge, and then I'm just append to our queue data structure also. Okay, which is the queue dot append. I'm gonna give here just the edge, and here whenever, for example, we didn't visit this node, yes, this, for example, edge also nodes, yes. Okay, and which are the, it means whenever we are storing in our list inside, for example, a just store like this, yes, it means whenever we took this as a, we can take as a node, I'll say, okay, which is a vertex. It means every time we are append our queue, and then we are here, and after that whenever we are using iterate using the while loop, whenever we are jumping to another next node, yes, and we in here I'm just dequeuing, which is the first node, yes, for example, and maybe here we are just dequeuing this node, and after that in our queue data structure we have a B. Okay, and then we are starting here as a B. Okay, and then we are continuously go whenever we reach the last node. Okay, and this is our breadth first search. It looks like how it is in the code, and let's want to check this breadth first search. And firstly, and this one I'm going to create the graph, which is this. I'm going to create this graph in the dictionary. Okay, which are the A, which is the B, C, D, and like so. Okay, and as you can see here, I wrote all nodes and also their edge. Okay, and then here I'm just going to give here to our graph, which is the graph node dict, and this. Okay, and then I'm going to cut this, and I'm just going to print using the, I'm just going to iterate my graph using the breadth first search. Okay, graph dot and dot breadth first search, which is the BFS, and then here I'm going to give the node. For example, I'm going to start from the A. Okay, and like so, and I'm just save it, and then I'm going to print this, and I was going to print, and you can see here we printed successfully, which is A, B, C, D, E, and if you can see here, first we are visiting A, B, C, D, E as a level of the traversal. Okay, and it looks like this, and this is all about breadth first search, how it looks like. And then let's want to create our next function, which are the depth first search. Okay, depth first search, which is based on this queue, and this is similar to this code. I'm just copy it, and here I need to change the variable is not, it will not be the queue. Instead we're going to stack, based on stack, and every time just want to stack here also. Every time we are popping, okay, which is the pop node, and then this is the last, it will be last node, and we spoke about the stack, which is the FIFO, which is the first in first out. It means every time we are adding node, and then we are deleting that node also, okay, immediately. And here also I'm going to change, which is the pop dot, and here, and like so. Okay, and we are visiting, and we are just checking every time, and then we are append this edge, and then here also I'm going to change just the stack, and like so. Okay, so this is how it is in the code. Okay, it's very, I'm just the here is the difference between we are just, whenever we are dequeuing this node, we are just deleting first node, and in our breadth first search we are deleting last node. Okay, and let's go and check our breadth first search is also, and I'm going to depth first search also. Yes, oh, I changed here the depth first search, DFS. Okay, and then here I'm going to call that DFS. Okay, DFS, save it, and open the terminal. Let's run it. Oh, I didn't change this variable to the stack, and here we are just defining as a stack. I just used here execute because we copy it. Therefore, okay, and here also that's it, and save it. Let's run one more time. And you can see here we are just visit, and this is all about the breadth first search. The first search looks like in our code. Okay,